Hello, my lovely viewers. You are all welcome back to this channel, Prof. One Tutorials. My name is Alfred Amprofi, and I'm here to help you today to look at another aspect under differentiation. Differentiation, for which the broader topic is still under calculus. So today we are going to look at how we can differentiate some of the derived trigonometric ratios. The derived trigonometric ratios. So let's look at some of the derived trigonometric ratios. So the first one is going to be cot x. We have the second one to be cosec x. Then the third one is going to be sec x. So these three are some of the derived trigonometric ratios. Now, in my previous video, we learned about how we can differentiate them. But this morning, we are going to look at how we can use these to solve some examples. So we are going to look at those examples in the next few minutes. So my fellow viewers, sit comfortably wherever you find yourself. Take your notebooks or exercise books, pen, pencils, calculators if possible. Then we can all do this together. So stay tuned. Example. Differentiate the following with respect to x. Differentiate the following with respect to x. So we are going to look at the first example. A, we have y is equal to x sec x. Y is equal to x sec x. Now, from this particular example we have here, the x is multiplying the sec x. And if you remember when we started with differentiation, anytime two functions are multiplying, then we use the product rule. So here we are going to use the product rule. So we have y prime is equal to, I'll first of all keep the first term, which is x, multiplying the differential of sec x plus, then I will now keep sec x, multiplying the differential of the first term, which is x. So now we have y prime to be equal to x times. Now when we differentiate sec x, we are going to get sec x tan x. This is the differential plus sec x multiplying, and when we differentiate x, we are going to get 1. So now we have y prime to be equal to x multiplying the whole of this, which is x sec x tan x plus sec x times 1. We are going to get the same sec x. So this will be the final answer for this particular question. B. B. Y is equal to cot cube x. Y is equal to cot cube x. Anytime a particular trigonometric function or trigonometric ratio is carrying an exponent, then you have to make a substitution. So over here, we are going to let any variable of our choice represent cot x. So let's say a be equal to cot x. So from here, we are going to differentiate a with respect to x. So we have the a over the x is equal to, now when we differentiate cot x, we are going to get negative cosec squared x. Negative cosec squared x. Now, we are now getting y to be equal to, over here, a is representing cot x. But from here, the cot x is carrying an exponent. So we are going to get y to be a cubed, because a is the whole of cot x, but cot x is cubed. So we are going to get a cubed. From here, we are now going to differentiate y with respect to a. So we have the y over the a is equal to, when you're differentiating a cubed, the 3 will multiply the a. So we have 3a. Then we are going to take 1 from the exponent. So we are going to get 2. So at the end of it all, we are getting 3a squared. So now let's find dy over dx. Dy over dx is basically equal to dy over dA multiplying dA over dx. Because when this take up this, we are still going to get the dy over dx we have here. So from here, we are going to multiply this and this. So dy over dA is 3a squared. So we are going to make substitution. So we have 3a squared multiplying dA over dx is negative cosec squared x. So now from here, because of the negative, we are going to write it in front. So we have minus 3a squared, but we know that a is cot x. So I'm going to substitute cot x here. So it's going to give us cot squared x, then multiplying cosec squared x. Cosec squared x. And this is going to be the final answer for dy over dx. Let's look at the next example. C. We have y is equal to sec squared multiplying 2x squared plus 3. So this is another example. From here, the trigonometric ratio or function we have here is carrying an exponent. So we are going to use a variable to represent this whole function. So we are going to let any variable of our choice. So let's say let u be equal to sec bracket open 2x squared plus 3, because this is the function for which is multiplying the sec. So from here, we are going to differentiate u with respect to x. Now, generally, when any letter is representing sec x, so let's say this y is equal to sec x. So we are going to differentiate y with respect to x. This is a general form. So we are going to get dy over dx is equal to, when we are differentiating, we are going to start from the function. And here, when I differentiate x, I am getting 1. Multiplying the differential of the sec itself. So when I differentiate sec, I am getting sec x tan x. So from here, my dy over dx is going to be 1 multiplying the whole of this. We have sec x tan x. So that's the same idea we are going to use when differentiating u with respect to x. So now we have du over dx is equal to, so just as we differentiated this, we started from the x. So here I'm going to start from the bracket. When I differentiate 2x squared, I have 4x plus, and when I differentiate 3, I have 0. After differentiating, then I have to now start from the sec. And when I differentiate sec, I'm going to get the same sec of the function we have here. Just like over here we had sec of the same function which was x. So of the same function which is 2x squared plus 3. Multiplying tan of the same function. So multiplying tan of 2x squared plus 3. And this is going to be the differential. So I still have du over dx is equal to 4x plus 0. We still have 4x. Multiplying the whole of this, which is sec into bracket 2x squared plus 3, and then tan of 2x squared plus 3. Now, my y will now be u squared, because the u is representing the whole of sec of the function 2x squared plus 3. So I have y to be equal to u squared, because the sec is carrying an exponent of 2. So I have dy over du is equal to, and when you differentiate u squared, we are getting 2u. So now we can get to the conclusion. Dy over dx is going to be dy over du multiplying du over dx. So I have dy over du to be 2u. So I have 2u multiplying, and I have du over dx to be the whole of this, which is 4x sec of 2x squared plus 3 multiplying tan of 2x squared plus 3. So now from here, The 2 will multiply the 4x we have here. So we are going to get 8x. 2 times 4x, we have 8x. Then we have u here. But from the substitution, we made u to represent sec 2x squared plus 3. So we have sec into bracket 2x squared plus 3. Multiplying the whole of this. So multiplying sec of 2x squared plus 3 tan of 2x squared plus 3. So from here, we have sec of the same function multiplying sec of another function. Then we are going to get dy over dx to be 8x. So when this and this multiply, we are going to get sec squared of 2x squared plus 3, then tan multiplying 2x squared plus 3. And this will be the final answer. The next example. D. Y is equal to cosec squared of x squared plus 1. And I'm going to look at how we can differentiate it. In my previous video, we learned that anytime any trigonometric ratio has an exponent, then we must make substitution. So let any variable of our choice represent the cosec. So let any variable, let's say, a be equal to cosec with the function x squared plus 1. Then over here, we are going to differentiate a with respect to x. We are going to differentiate a with respect to x. The a over the x is equal to, when you're differentiating a function like this, we are first of all going to start from the bracket. So when I differentiate x squared, we are going to get 2x plus the differential of 1. So I have plus 0 because 1 is a constant. Before I differentiate the main trigonometric ratio. So when you differentiate cosec, we are going to get minus cosec of x squared plus 1, then cot x squared plus 1, because that is what we have within the bracket. Now from here, because of the negative we have here, we are going to write it in front. So we have minus 2x plus 0, we still have 2x. Cosec of x squared plus 1, then cot x squared plus 1. And this will be the dA over dx. Now, we said we should let A represent cosec x squared plus 1. So if that's the case, then y is going to be a squared, because a is representing this. But because of the squared, the a need to be squared. So from here, we are also going to differentiate y with respect to a. So we have dy over dA is equal to, when I differentiate a squared, I have 2a. So over here, dy over dx is going to be dy over dA multiplying dA over dx. Dy over dA is 2a multiplying dA over dx is the whole of this. So we have minus 2x cosec of x squared plus 1 cot x squared plus 1. So over here, we are going to make substitution. So we have 2 multiplying minus 2x, then we have minus 4x. Negative 2x times 2, we have minus 4x. A is the whole of this. So we are going to make substitution as well, which is going to be cosec of x squared plus 1. Then we still have the remaining terms here for which we are going to add up. So we have cosec x squared plus 1, then cot x squared. E, we have y is equal to sine x all over root x. Sine x all over root x. Now from here, this is fraction. And when you're differentiating function in a form of a fraction, then we are going to use the quotient rule. So with the quotient rule, I'll first of all maintain the denominator. So I have y prime to be root x. Then I'll now differentiate the numerator, which is d dx of sine x minus, I'll now maintain the numerator, which is sine x multiplying the differential of the denominator, which is root x all over the denominator squared. So we have root x all squared. So we are moving on. So we have y prime to be equal to root x multiplying. Now when we differentiate sine x, we are getting cos x minus sine x of, and when we are differentiating root x, we are supposed to first of all rewrite root x in an exponential form. So we have d dx multiplying x exponent half all over, and when I have root x squared, the squared will take off the radical sign. So we have x to be the denominator. So now let's differentiate this. So I have y prime to be equal to root x multiplying cos x. Root x cos x minus sine x multiplying, and when I differentiate x exponent half, the half will first of all multiply the x. So I have half x. Then I'll take 1 from the exponent. So I'm going to get negative half all over x. So we are moving on, which is root x cos x minus sine x multiplying. Because the exponent is negative, then we can bring it down to be a denominator. And the moment we pull it down, the exponent changes to be positive. So 1 over 2x power negative half is the same as 1 over 2x power positive half. This is the same as this from indices. All over x. So now I still have y prime to be root x cos x minus sine x multiplying 1 over 2. And from here, the x power half is the same as root x all over x. So from here, we are going to simplify this because we have a fraction in there. So we have y prime to be equal to root x cos x minus sine x all over 2 root x. So from here, the sine x is over 1. So sine x times 1, we still have sine x. 1 times 2 root x, we have 2 root x all over x. Now from the numerator, the whole of this is over 1. So we are going to take the LCM. So we have y prime to be equal to, now the LCM of 1 and 2 root x, we are still going to get 2 root x. When 1 goes into 2 root x, we still have 2 root x times root x cos x. We are going to get 2x because root x times root x will give us x. Then cos x, for which we have here, minus 2 root x goes into 2 root x once times sine x. We still have sine x divided by x over 1 because we have all over x. So now we have y prime to be equal to 2x cos x minus sine x all over 2 root x. Because it is dividing x over 1, then we can change it to be 1 over x. So from here, everything from the numerator times 1, we have 2x cos x minus sine x all over, and 2 root x times x, we are going to get 2x root x. And this will be the final answer for this particular question. Let's look at the next question. F. We have y is equal to x power 4 then cosec of 3x. So you are supposed to differentiate this. And over here, the x power 4 is multiplying the cosec 3x. And because two functions are multiplying, then we are supposed to use the product rule. So we have y prime to be equal to, I'll first of all maintain x power 4, multiplying the differential of cosec 3x plus, then I will now maintain the cosec 3x. So I have cosec 3x multiplying the differential of x power 4. So this will be the first step. So now I have y prime to be equal to x power 4 multiplying. Now when we differentiate cosec of 3x, as we normally do, we are going to start from the bracket. So when I differentiate 3x, I have 3. Before, I'll now differentiate the cosec. And when we differentiate cosec, we have negative cosec of the same function, 3x, multiplying cot of the same function, 3x. And this is going to be the differential. Plus, what I have here is cosec 3x. So I have cosec 3x multiplying the differential of x power 4. And when I differentiate this, therefore multiply the x. I have 4x. Then I'll take 1 from the exponent, getting 3. So now we're going to evaluate this. So from here, the 3 will multiply the x power 4. So we have y prime to be 3x power 4. Because of the negative, we are still going to write it in front. So I have my negative here, which is going to be negative 3x power 4. Then I'll repeat the whole of this, which is cosec of 3x cot of 3x plus, and here the whole of this is also multiplying the 4x cube. So we have 4x cube cosec of 3x. And this will be the final answer for this question. The next one, J. We have y to be equal to 2 sine cube of 2x squared plus 3. Sine 2 sine cube of 2x squared plus 3. Over here, the sign is carrying an exponent. So we need to make substitution. So we are going to let any variable of our choice represent sine. So we will let m to be equal to sine of 2x squared plus 3. So after making the substitution, then we are going to differentiate m with respect to x. So I have dm over dx is equal to, because what we have in the bracket is 2x squared plus 3, we need to start from the bracket. So we are going to start the differential from the bracket. And when I differentiate 2x squared, I have 4x plus. And when I differentiate 3, I am going to get 0. After differentiating what we have in the bracket, they will now differentiate the sign itself. And when I differentiate sine, we are getting cos of the whole function 2x squared plus 3. So now I have the m over the x is equal to 4x plus 0. We still have 4x multiplying cos of 2x squared plus 3. So this is going to be the dm over dx. Now my y is going to be 2. Now the sine of the whole function is m. So we have 2m cubed because the sign here is carrying an exponent of 3. So I have 2m cubed. 2m cubed. So if that is the case, then I have dy over dm to be equal to, now when 3 multiplies the 2, I have 6m. And difference 1 from the exponent, I have 2. So since we have this, then we can now get the dy over dx. So I have dy over dx is equal to dy over dm multiplying dm over dx. Dy over dm is 6m squared. So I have 6m squared multiplying dm over dx is what we have here, which is 4x cos 2x squared plus 3. So now from here, we are going to make substitution. But before that, 6 times 4x, we are going to get 24x. And what will follow is the m squared. But from here, my m is sine of 2x squared plus 3. So when I put the squared there, then I'm going to get sine squared of 2x squared plus 3. Then I'll just continue with the cos, which is cos of 2x squared plus 3. And this is my dy over dx. This will be the final answer. H. We have y is equal to tan x all over x. We have tan x all over x. Over here, tan x is dividing x, and we are going to use the quotient rule. So we have y prime to be equal to, with the quotient rule, we are going to first of all maintain the denominator, which is x, multiplying the differential of the numerator. So we have d dx of tan x minus, we will now maintain the numerator, which is tan x, multiplying the differential of the denominator, and that is x all over the denominator squared. So now we have y prime to be equal to x multiplying. Now when I differentiate tan x, I am going to get sec squared x minus tan x, also multiplying the differential of x. And when you differentiate x, we are getting 1 all over x squared. So now let's check the final answer. So I have y prime to be equal to x multiplying sec squared x. We are going to get sec squared x minus tan x times 1. We are getting tan x all over the denominator, which is x squared. And this is going to be the final answer, which is very, very simple. The next one, I. We have y is equal to cos exponent 9 of 4x. Y is equal to cos power 9 of 4x. So we are going to look at how we are going to find the differential. Before we can differentiate this, because it is carrying an exponent, then there is a need for us to make substitution. So we are going to use any variable of our choice to substitute cos of the function. So we are going to let any variable, let's say u, be equal to cos of the whole function for x. After making substitution, then we are going to differentiate u with respect to x. So we have du over dx is equal to, from the bracket we have 4x, and that is where we are going to differentiate from. So when I differentiate 4x, I have 4. Then I will now differentiate the cos itself. And when I differentiate cos, I am getting negative sine of the function, which is 4x. So because of the negative I have here, I'll get du over the x to be negative 4 sine of 4x. So this is going to be the differential. Now, my new y is going to be u exponent 9. Why? Because u is now cos of the function. But you know the cos from y is carrying an exponent, which is 9. So we have u power 9. And from here, we are going to differentiate y with respect to u. So I have dy over du is equal to, anytime we are differentiating where we have an exponent, the exponent must multiply the u. So we have 9u, difference 1, we have 8. So now we are going to get dy over dx to be equal to dy over du multiplying du over dx. So this is how we are going to present it. So we have dy over dx is equal to, now from here, dy over du is 9u power 8. So we have 9u power 8 multiplying du over dx. And du over dx from here is negative 4 sine 4x. So now we are going to multiply the negative 4 by the 9 we have here. And negative 4 times 9, we are getting negative 36. U power 8. And we have u here to be cos of 4x. So now it's going to be cos power 8 of 4x, because u is cos 4x. Then we now add the sine 4x to it. So we have sine of 4x. And this is the final answer. The next example. J, we have y is equal to cos 2x all over sine x. Cos 2x all over sine x. From here, we are going to use the quotient rule because two different functions are divided. So now we have y prime to be equal to, I will first of all maintain the denominator. And we have the denominator to be sine x. Multiplying the differential of the numerator, which is cos 2x, minus, then I will now maintain the numerator, which is cos 2x, multiplying the differential of the denominator. So I have d dx of sine x all over, then I will now square the denominator. I will square the denominator, which is sine x all squared. So from here, I have y prime to be equal to sine x, multiplying, and when we differentiate cos 2x, we are going to first of all start from the bracket, which is 2x. And when we differentiate 2x, we have 2. Then we now differentiate the cos itself, and that is negative sine of the function we have. So of 2x minus cos 2x that we have here, also multiplying the differential of sine. And when you differentiate sine, we are going to get cos x all over sine x all squared. And we have sine squared x. So now from here, the 2 here will multiply the negative we have. And we have minus 2 sine x multiplying sine 2x minus, then the whole of this, which is cos 2x cos x all over sine squared x. And this is going to be the final answer. The next example. Okay. We have y is equal to 2x cubed, then cos of 3x. 2x cubed multiplying cos 3x. So, my fellow viewers, before we differentiate this, if you see this video to be very educative and helpful, kindly like this video Don't forget to subscribe if you haven't subscribed yet. Share your comments in the comment section, and you can also share this video as many as possible. All right. Now, before we differentiate this, the 2x cubed is multiplying cos of 3x. So we are going to use the product rule. So with the product rule, we are first of all going to maintain the first term. So we have 2x cubed multiplying the differential of cos 3x. So multiplying cos 3x plus, then I will now maintain the second term, which is cos 3x, also multiplying the differential of the first term. And we have 2x cubed. So we have y prime to be equal to 2x cubed multiplying. Anytime you're differentiating where we have a function in a bracket like this, then we are going to first of all start from the bracket. So when I differentiate 3x, I'm getting 3. Then I'll now differentiate the cos itself, and we have negative sine of the function 3x plus we have cos 3x, also multiplying the differential of 2x cubed. And when I'm differentiating 2x cubed, the 3 here will multiply the 2. It will give us 6x. Then I'll take 1 from the exponent, giving me 2. So from here, we are going to evaluate. So I have y prime to be equal to, there is negative here, times 3. We are going to get negative 3. So we have 2x cubed multiplying negative 3 sine 3x plus, and over here the 6x squared, we are going to write it first. So we have 6x squared cos 3x. In conclusion, I have negative 3 also multiplying 2x cubed, and we are going to get negative 6x cubed with sine 3x plus then the remaining function, which is 6x squared cos 3x. And this is the final answer for this particular question. The last example. L. We have y is equal to cot multiplying x squared minus x. So we have y to be cot x squared minus x. Before we can differentiate this, we are going to start from the bracket. And when I differentiate x squared, I have 2x minus, and when I differentiate x, I have 1. After differentiating what we have in the bracket, then we now differentiate the cot itself. And when you differentiate cot, we are getting negative cosec squared of the entire function. So of x squared minus x. And from here, because of the negative, I will bring it in front, which is y prime equal to negative bracket open 2x minus 1 cosec squared multiplying x squared minus x. And this is the final answer. So my lovely viewers, we'll end here for today and we are going to continue in the next video. So in my next video, we are going to start with the integration of the trigonometric ratios. Can you like every video you watch from this channel? Don't forget to subscribe if you haven't subscribed yet. Share your comment in the comment section and stay tuned. Bye bye.